If anyone sees Chris, if anyone knows who Chris is, problem is he has the more interesting part of the presentation, well, of the workshop. I'm David, in case you don't know me. Hi, welcome. This is the FRR workshop. First of all, there was a call earlier from some people who aren't attending about maybe having a meetup. I will probably try to organize that if you need FRR, if you're interested in meeting up with us. It might be Thursday, it might be today. It's probably not going to be tomorrow because of the soccer game thing. Not sure if it's actually going to happen. Just come up after the workshop and we'll figure it out. I'm going to go through a quick summary of the changes in the last two releases. The management D stuff and the Yang stuff is Chris's part of this. I don't know where he is, so I have a bit of a boring, well, maybe funny stuff about restructuring our debug infrastructure. It's not the most interesting stuff, but it is kind of a sad story. We did have multi-step and recursive FIB support on the agenda. That didn't quite happen because people who really know that stuff didn't make it here. And it was a bit of short notice. So we can still discuss that separately if people are interested. I don't know what the spread around here is. We've had two releases since the last NetDevConf 9.1. I've cut this down to changes that are, well, call it back-end, low-end. We changed the way recursive routes are resolved in Zebra, which is a bit of a detail. Maybe more interesting for context here is that FRR is extending the feature range to more traffic manipulation features, i.e. VLAN, ECN, and DHCP manipulations that we are starting to extend it into PBRD. Zebra did gain or improved its TC backend, so there's going to be slow increase in terms of things that Zebra can install into the kernel in outside of actual routing updates. Some of this is BGP flow spec, some of this is just policy configuration from the admin. There's a whole bunch of protocol-specific changes in these releases that I didn't include here. I don't think they are super relevant here, and you can all read the changelog if you need to. 10.0 had a bit more relevant changes here. The split config thing I'm mentioning here because if you run FRR, especially as a developer, and you have some kind of test setup or something, and you're maybe not a super FRR user, split config is the old style of having a Zebra conf, BGPD conf. That is no longer really supported. Part of this is the fact that management D is coming along, and it doesn't quite work with that. So you need to use a FRR.conf now and load it with UI shell at startup. So that doesn't happen automatically when you load the daemons. We did have a whole lengthy, I don't know, bug hunt is the wrong word maybe, but chain of issues with no prefix route. Who here knows what that flag does? No prefix route. It's an address flag on Netlink. Okay. Well, it's primarily used by Network Manager, and it causes the addresses when you install them in the kernel to not get a route in the routing table, which Network Manager uses because it wants to do that itself. And it turns out that causes a whole lot of pain for FRR because FRR really expects that route to be there when the address is added to the kernel. It listens to the address notifications on Netlink, and then having the route be a separate thing just broke so many things. I have to say, to some point, it's a really weird setup to have Network Manager on your router, but people do that apparently because we did get that as bug reports. There were multiple changes to try to get this to work. It's still not done. I think there's still an open PR to change how it works again. And the other major change in 10.0 is that we started doing local routes, as in routes for the addresses that the host actually owns. This is something that has been a disparity between FRR and other routing stacks for an extended time. So these are now at least shown in routing overview, and they exist as a type that can also be redistributed. Notably, on Linux as well as the BSDs, in fact, they would in fact exist in the routing table, but we don't currently pick them up from there. They are just generated inside of Zebra from the address internally. That's another discussion that is ongoing. Should we pick these up from the kernel, from the local table, or do we keep them on the address? It looks like it's drifting towards changing it and in fact picking them up from the kernel. At least that could maybe prevent some further desynchronization, although I'm not entirely sure how and where that would happen. Again, there's a bunch of protocol-specific changes in 10.0 that I'm not going to go into a whole lot of detail here. And none of those protocol changes are, at least as I remember, specifically relevant for the backend, well, lower network development like the XLAN specific features or anything like that. It's just general, in particular OSPF and ISIS features that we had in these two releases. There's some general things that are going on in FRR. Multicast routing for IPv6 is just slowly maturing. It's been in since I think 8.4, 8.5. It's basically not, it's leaving the point where we are calling it experimental on our end. I think there have been 2 small patches to the Linux kernel multicast forwarding code that came out as a result of this, and both of those were 2 years ago, 3 years ago. Those have been in for quite some while, and it doesn't look like there's anything else that needs to be fixed for IPv6 multicast routing. There's, of course, still a kind of permanent problem that the multicast routing API is, let's call it dated. It's the original API from BSD from 1990 or something. And it's not great. There's a whole lot of work going on with the data plane backend in Zebra. Some of it for other data planes, but a whole lot of it for the Netlink backend to try to decouple it from Zebra, have it be in a separate thread and move things over there. I think right now Zebra has 4 Netlink sockets, which it's a lot, but they're spread across different threads, and 2 of them are notification sockets and 2 of them are command sockets. So it makes sense if you look at how they're used. Yeah, that's the general updates. I'm going to pause you for a second in case anyone has questions or want me to go into anything specific. I guess not. This is where I would hand over to Chris. So maybe he shows up later, maybe he doesn't. Worst case, the presentation is going to end early, I guess. I was planning to talk about debug flags. I was kind of planning to have this hang at the end of the presentation and kind of hoping that we wouldn't even get to it. Can I get a raise of hands of who has written actual code for FRR or looked at FRR code at all? Okay, that's 1. Okay, everyone else is going to be bored, or maybe you're going to laugh because it's a story of how bad things can get. I guess everyone here is at least reasonably aware of what the debug infrastructure is supposed to do. As it turns out, FRR has a lot of historical baggage here, and it's degenerated to a place that is not really tenable anymore. In the simplest case, this is what we are talking about. Where did my presentation go? Here. The very simplest thing is to just have conditional debug statements. It's easy, it works. Unfortunately, that's not what all of the code in FRR does. People started adding wrapper macros for this stuff, so it looks like this. It's a trivial change. it's inconsistent because, again, that's not all of the locations that use this. We started having people define more macros for this. In this case, it was the whole infrastructure that defines debug flags as structures and tries to enumerate them, tries to do special CLI for them. This didn't make it to a lot of code in FRR either, because you always start this stuff and never finish it. This is what it looks like from the code. Could zoom in on all this stuff. Don't know. Whatever. For bonus features, this one also has variants where it creates debug warnings and debug errors, which I don't think those are used a lot. There's, I think, 2 warnings, 1 error. I have no idea how this makes sense at all. I will point out the ampersand here because it's going to come back to bite us later. And when I say later here, you can see this is going to take a bit of a longer tour. We have a few places where we do this callback pattern for log messages, in particular with external libraries. Unfortunately, the PSEP code in FR is essentially an external library, even though it is straight in the code. So that also uses this pattern. I'm going to jump back and forth here. Yeah, it's you can imagine what the code looks like. I'm pulling a little bit ahead here, mentioning a message index. This breaks creating an index of all the log messages. I'm going to get to that in a few slides. Lastly, in existing log message invocation types, we have these wrapper functions. I think we got rid of all of them. So LDPD was a major user of these, and it had its whole set of, I think we deleted the whole file somewhere in the between of this change. I shouldn't have zoomed in. Now it lost my scroll position. Doesn't matter, they're gone. The point that actually led to this being part of the presentation is that we ended up with 3 different PRs that all try to address this. I was hoping for more FR people to be here and maybe be contributing to the discussion, but I guess you just get this to be a bit of a horror show. And yeah, the first one is similar to what I've already shown you with this uppercase debug thing. It tries to create data structures for the debug flags and have them be more, touchable, I guess. This is a pretty large PR because it does, in fact, try to change the code that's actually using this. It didn't quite. Okay, you can see the diff stat up here. It's just shy of 10,000 lines. A lot of this is automated with Coccinelle, but as you can also see, it's still a draft. We have another one that just tried to move things around regarding how the CLI is done for the debug statements. Doesn't do a whole lot of changes to the existing code. It just changes how the commands are installed in the configuration of the CLI. And we have a third one that adds yet another way of moving the flag check into the debug calls. It only did this in a very spotty way, but it does show that we are in a situation where people just repeatedly try to improve this, and people aren't aware of the work that other people are doing, and everyone kind of comes up with the same thing. And each of those has issues to some varying degree, and making things worse, sometimes making things better. Oh, Chris. Oh, okay. Yay, we get to hear about management team. I'm gonna stick through the debug stuff and switch over to you. Wanna go in your? Okay. Why am I even talking about any of this? We need to fix the situation, and even more, maybe more important, maybe less important, we do have a message index in FRR that is very similar if you know this Linux kernel print k index feature. I will point out we actually had this before the kernel. It's a point of personal pride. This is what our index looks like. We do actually assign unique identifiers for log messages, and the code does print them on each log message. It is in fact a SHA-256 of the format string and the file name, I believe, and the priority. So it's reasonably consistent, and we extract those from the binary, like you can do with the kernel as well, because it's a separate section in the ELF file. We also started adding features that can refer to individual debug messages. So this is already in the code since 8.4, I believe. You can just turn on backtraces for specific log messages. And of course, this only works because you can identify a log message by this identifier. And it's in particularly relevant since all of the daemons in FRR are something that as an operator, you don't want to restart a lot. You don't want to flap your internal routing domain, your OSPF, your BGP. And even though in theory, you can just attach a debugger, the moment you attach a debugger, you're causing timing issues. And it's issues across other routers participating. So it's never a good situation if your GDB stops your routing daemon and you're just there for a minute or something. We do have an interest in extending this further. We can't currently enable or disable individual debug messages. They're all gated behind these larger groups of debug flags. And unfortunately, there are several of these flags that you can't really enable on an operational network because the amount of debug messages is just too large. Purely the formatting and the writing out is costly. We do, in fact, have at this point a buffering infrastructure for debug messages. There is a thread local, I think it's 8 kilobytes somewhere that all the debug messages get written to, and they get flushed out when you have a non-debug message that just bumps out all the other stuff that has been buffered. And that does help quite a lot because we don't need to call write for each single message. We do want to add to the index that I showed earlier which debug flag controls a specific debug message, which is something that operators ask for. It's the way to find out what debug flag you need to turn on to get a message is normally to read the code, and reading the code is not something that we like to tell people using FRR. Not everyone can do that. Not everyone wants to do that. We are also looking at making debug messages kind of perf counters. It's mostly interesting because it gives us numbers on which part of the code is actually hit. Even if the debug messages are disabled, there's, considering the size of FRR at this point and the number of, call them exotic features, we don't have a good way to figure out what is actually being executed, how widespread using some features is, and having just counters on some of the debug statements would help a lot to get numbers on this. How to collect this is a separate question. We don't have any kind of telemetry at this point, and that's a whole separate topic. But just having the numbers to begin with would enable us to go further there. So overall, the hope for all of these debug messages is that we can make them more tangible by having these checks moved into the common debug infrastructure and have the check move there and have that be after, for example, those counters I just mentioned. Unfortunately, that means that we have to touch everything, since if the code has this just pure C if condition check before the debug message, there's nothing we can do there. There's no amount of C preprocessor magic can give us any access to that. So where that leads us naively is just to have it be part of the macro, which boom, boom, boom. That's not it. Let me pull the code up. Wrong file. This is the right file. It's quite lengthy. So this is the current suggestion at replacing the debug invocations. All of this stuff here is in fact part of creating the index. The way it works in FRR is that there's two structs being emitted because one of them is read-only and the other one is actually read-write. The actual debug invocation is just this part down here. It's actually even only those 3 lines. There is a little bit of extra specificity that I'm going to circle back here. That said, this PR has been discussed for 2 years, 3 years at this point. It's very slow moving. And as it turns out, there's some unexpected cost from this, which, to be fair, mostly shows up in micro benchmarks when all you're doing is calling into debug calls. I'm not sure if this is just us being unaware of things. Maybe this is a common knowledge. But as it turns out, it's surprisingly costly to have the compiler do VA start because the compiler doesn't know that we don't really care about printing floating point values. It still has to push those. It doesn't know by the time you're in the varargs function that the set of stuff that it pushed, it knows, in theory, the compiler knows what it needs to save, but neither CLang nor GCC are particularly capable of carrying this information down into the actual function that does the varargs conversion from the triple dots to the VA args type in C. And that does show up, at least in micro benchmarks. To me, it was at least surprising. I'm not sure if it's surprising to other people. The obvious solution to this is to have the actual call with the format parameters after some type of conditional check, which in this case means that we need to move the conditional check itself into the debug infrastructure. Again, it's relatively simple from the code. It was just a matter of noticing that it's an actual problem. So it will need to work like having zlog test be a function in the debug infrastructure that does these checks to see if the log message is in fact enabled, but it doesn't get the actual argument to the message because that's the part that turned out to be costly. Yeah, it is 2 function calls if we do print the debug message, but that's not the case we care the most about. The case we care the most about is that zlog test is going to return false. It may by that point already have done the counting, for example, but yeah. And then, because things are never simple, we have further complications from the fact that FRR has, in some cases, parameterized debug flags, so to call them. If in BGP you enable update debugging, you can tell it you want to do update debugging only for a specific prefix. This is, in particular in BGP, it's used a lot, and it is, again, quite important because it's costly to print these debug messages. And you can see this debug check takes 4 different parameters here. And somehow reconciling that with the want for having all these debug messages be tenable, touchable, kind of, and having features on them is, well, non-trivial at the least. And that's where we get back to that ampersand that I mentioned earlier in one of the pre-existing debug macro types. As it turns out, that ampersand, that single byte, is killing a whole lot of venues that would enable us to, in fact, have this debug infrastructure and still have it work with the parametric debug messages. And I can jump back here. This single line here with token pasting the debug flag into the check. If you don't have the ampersand in here, this can actually be a function call. I don't think I have an example for this around. Let me jump here. I should have added a slide for this. Well, I can use this example. No, use this one. Flag here can actually have braces after it and contain parameters. That only works with very specific trickery with a preprocessor. because it does allow you to paste things in front of it, and then it will keep the invocation intact. It's very specific, but the end of the story is the ampersand is kind of killing us. If it wasn't for that single thing, we could have just kept that one existing approach of the 4 or 5 that are already in the code. But yeah, can't do that because we can't get rid of that one byte. Lastly, we did look at the numbers for getting those features to work. If you're a kernel person, you know it is surprisingly costly to do all this with support for running across multiple CPUs. We have overused atomics in FRR, I will freely admit. Sometimes it would in fact be cheaper if we do locks instead, but we do need something along those lines to do those counters for the debug messages. RSec is increasingly looking like it might be usable for this. We may have issues with support for older distros that we need to support for this. But yeah, we are looking into it. What it's going to look like, we don't know yet. It is still ongoing work. Yeah, that is my little tour through the disaster that is debug messages in FRR. Those are the 3 things I would list as takeaways. Don't ever put the ampersand in the macro invocation. Don't underestimate how costly it is to do the ARC calls. And lastly, don't let it get this bad. I hope this was reasonably, I don't know, funny horror story. Does anyone have questions about the debug stuff? Okay. Do we have a second microphone or do I? Okay.
For your counters, have you considered using perf trace points in user space?
Sorry, have you considered?
Perf trace points in user space. You don't have to do all this stuff of doing your own atomics and stuff.
So we do have LTTNG support, and we do have system tab support. I think those are kind of the same thing, but different again, right?
LTTNG is built on top of perf.
Okay.
We have found it to be quite complicated to use. Just basic user space perf trace points are much more lightweight. They may actually solve your counter problem. And the other thing is also looking into using, all this debug log support. If you look in DPTK, they've added BPF support. You should maybe check into that. That might be a nicer way to just have callouts when you need it. And
so I think the primary argument against those is that we want this to be a unconditional feature that is always enabled in FRR and that doesn't need you to do any additional setup. So in the ideal case, these counters would always be enabled for all debug messages in all installations of FRR.
With just adding a perf trace point on your zlog function, you could have this counter. We do that all the time. And,
I would need to have it on the call side to the zlog function, right?
You don't have to change the code. You can do it at runtime.
Okay, but I would need to put it in every single debug call.
So let's talk about this offline.
Yeah, okay. Other comments, questions?
Just regarding that, we looked at the VPP, how they do it? Well, VPP just does a per core, and then they have a big lock. So every once in a while, they synchronize all the data. Yeah, okay. I didn't know what RSec was. So
Do people here know what RSec is? Who knows RSec? Aren't you supposed to be super fancy hackers? RSec is restartable sequences. It's gotten added to the Linux kernel, I think, a year ago or something. It needs support from the C library, and what it does is there's a way to the kernel to tell that you are right now for the next 5 instructions in kind of a critical section, and you tell the kernel that if it does a task switch in the span of these instructions, that there is a recovery point where it should jump back into on task switching back into your task. So the assumption is that you are not going to task switch in those 5 instructions that the CPU is doing. But for the rare case that you do, you tell the kernel, don't go back where you interrupted the code, but go to this restart point. And that combines with the kernel telling you what CPU or what scheduling ID you're running on, which means you can do per CPU counters. And they're, yeah, exactly, without locking and without atomics. Cool. I think that means we move on to management team.
Great. So this is a basically discussion of a pretty short presentation on the new management D, which is management daemon. This is a centralized management daemon in FRR. So the original management framework in FRR involved btysh by shell, which you would enter config commands or show commands, config commands up there. And then depending on some routing knowledge, it would send each VTY, each line, it gets sent to each daemon. And then inside each daemon, there's CLI handlers that parse those lines. And then part of the CLI handler is C code that then changes the values within the daemon. So this is what we had before, what was called the northbound the northbound conversion. So this happened a while ago. I don't know what when did northbound happen? 8.0. So the northbound conversion was bringing Yang in, and 7.0. So what happened here is we have the VTYSH, we have the command, and it comes down into the handler. But instead of the handler modifying the running code, the handler issues a Yang config, which then goes into the Yang database. Sorry if you don't know Yang, it's basically modeling language, right? So it's describing state. And so it's just a schema of state, right? So you have this sort of modeled, defined state for your config and your operation, also operational state that you fetch. So this here is a path, right? So kind of pretty obvious, right? Into the interface module, under the interface, it's like, right? And then the description. So we're modifying the description on an interface. So we'd modified the Yang database, and then part of the new northbound code gets this change, and then it calls these callbacks that we created, right? So we basically associate callbacks with the path. So now the flow is the CLI command just changes the standardized schema, and we've defined callbacks for each leaf or node in the schema. This gets called, and then that now does the change. So this has been there for a little while, although not all the daemons have been converted to it yet. So what happens now? The problem with this is we still have VTYSH. We still have VTYSH talking to each daemon. There's no centralized point to actually control the entire router. You're controlling daemons, which is not very useful for how people actually want to manage routers, right? Here's an example. BGP hasn't been converted, so it's still utilizing the old method. So what we needed a centralized daemon, and that was management D. But now, what we did was we moved the CLI handlers out of the daemons, the same code. No new code needs to be written. We just linked the CLI into management D for and converted. So all the handlers are up there. VTYSH1 And the handlers do the same thing. They change it. They do a Yang database change. This is handled through what's called the front end interface now. That's just a way of transferring the Yang change. So that transfers over to the front end adapter, goes to the Yang database, just like we saw in the daemon cases, right? But it's in centralized. And then the new addition here is we have the back end adapter, which then takes each of these Yang paths and carries it out to whichever daemon it should go to. And this is the same callbacks that we talked about earlier, right? That handle paths from the Yang database. So basically, it's a central repository for the Yang database, right? And each daemon basically signs up for the paths that it's interested in the schema. And what does this allow? Well, now we have gRPC, netconf, restconf, v2ish. They're all talking this Yang and all to one daemon. FRR is just one point of connection. Your RESTconf server talks a management D, and that's it. And so when your RESTconf client connects to the RESTconf daemon, you control all of FRR with a single client, with a single connection. Any questions so far? Yeah. Yes. So this is not it's not synchronized to this database up here. It's just the stuff that it's interested in, right? It doesn't need to know the rest of the stuff because it's not going to act on it. So this I'm not going to go. This is in the developer docs, right? And I don't expect everyone to be able to actually parse this. The other thing that's interesting. This is the operational state. Different config state. You're pushing the change down to the daemon, right? Operational state. You're fetching data from the daemons. So this is just the detailed drill down on the function calls, literally from v2ish. Sounds like something. Okay. Maybe it's my presentation. So this v2ish is talk. It's basically it talks to the front end, which is management D. Management D then sends the query, which is another XPath question, to itself. That's how the CLI works. But it could be a RESTconf server talking to the main daemon. This is showing it go from the front end adapter through the transaction module to the back end adapter. And again, we just basically have subscriptions. You know, each daemon subscribes to certain paths, saying I supply state for this path. So when the management D it gets a query. State for that path, and it fires off the queries, all of those daemons. And then it collects them back here, it merges them all together, and then sends them back to the user. So this is just showing the routing, right? This is like config routing. So you'll see the route map, interface, filter, and VERP. These are common between Zebra and RipD. And then the red ones, Zebra and Affinity, RipD and Keychain. These are different, right? So everything that goes to the yellow on the yellow pass will go to both daemons. But something going to one of the red paths is only going to go to that one. And this is just example of oper state. In this case, it's again just I'm subscribing to the whole interface module. Now, what I'm going to return from that will probably be Zebra specific there. Well, RIP doesn't have it going. I don't have any yellows there, so they're all unique. Yeah. The keychain, though, is in lib, so it's not RIP specific. I'll show that in a minute. And then, so there's one more, there's actually two more actions, but there's one more that you subscribe for in a daemon, that would be RPCs. So this would be like, and this RIP is just subscribing to the entire RIP module. That would be like clear counter, right? So that's a way that you do an RPC. within netconf or sconf or any of those. Or in CLI, you'd be typing clear rip. So where are we at in the status? So we've converted these daemons here and all these library modules all the way to management D. Northbound config that hasn't gone to management D yet are these 4 daemons. These have been converted, but they need to be fixed. Moving from the right hand to the left hand is incredibly easy, actually. It maybe like somebody who's done it before, it would take them less than a day to move the daemon from northbound config. And again, that's because you remember all we did was we moved the CLI handler up, right? And we're still utilizing the same backend calls that we already did in the northbound config. So it's just moving code. Not actually having to write any real new code to go to management D. And that was a huge design goal for us when we did management D design. Was we already had this example of things that haven't even been converted to northbound yet, right? So we didn't want to add yet another thing that wouldn't get done, right? So management D needed to be almost free. And so that's where the design came from. Why it utilizes this. So yeah, we still need help here. So anybody who knows anybody, if you know interns or you are an intern or a college kid, or you're looking for a cool project, Google Summer of Code. These daemons would be great help to us to have these converted. And then the last slide is just, this is documentation on the northbound conversion. Very, very great documentation. I don't know if Renato did like I think the whole implementation of northbound. It's really excellent work. So kudos to him, and it's very well documented. So it's pretty easy to do conversion. It does require work though. I mean, it's not, when I say easy, it's easy to understand, right? But there's still work to do. The management deconversion is like, couple, maybe 4 or 5 scrolls in a web page and describes everything you need to do there. So that's it. Any questions? Okay, I bored everybody. Well, anyway, the cool thing, right, is we have a real big demand for RESTconf and netconf servers and being able to manage, FRRouting installations through automation. And so that's what this is all about, is getting to the point where you can manage your whole network with automation tools that don't do screen scraping, CLI, Okay, thanks.
Just a reminder, I mentioned this meetup thing at the beginning. If you're interested, I'm not quite sure how, where, when, if we're going to organize that part, but there are definitely some FR people that can't attend NetDevConf, so we will try to have some get together maybe today in the evening, maybe Thursday in the evening.
Can anyone hear people from Zoom? Because no one is reading the chat.
Oh, that is not good. I think I can join that. Give me a second. Are there people that have questions? I assume that's a yes if you're. Okay, if you can unmute yourself, then go
I sent a question to the chat.
Oh, can you repeat it on?
Is there a plan to add atomic config reload functionality to FRR itself instead of using FRRreload.py? And I cannot hear any of you when you are away from the mic.
Okay, I see. Yeah, so yes, there are, I wouldn't call them atomic, but what we do have as part of the northbound conversion, which also continues on with management D, are transactions. So instead of it being like the old Cisco CLI where it executes each line as you enter the line and then it immediately takes effect, it's that sort of new method where you enter into a change period, right? You say conf T or whatever, and then you make all the changes, but they're not committed. And then at the end you say commit. And then all those changes happen at once. They're validated together and then they're applied together. So that's fully supported now. It's not the common use right yet. Like we don't know a lot of people using it. I do know one person who did work on this code a lot, who was testing it. So it is run and tested.
It's a lazy question, but have you updated the Python code to support that? And if not, do you need help with it? Because I'm very interested in that functionality. I know my speech is terrible, but could you?
We haven't changed the FRR reload code. No, that's still the same old. It's all new functionality. The transaction stuff is new functionality. I don't remember if I don't think we have a test right now for swapping the whole config out with a new config. Technically, it should work just like a giant commit. I didn't go into details, but the Yang database is actually a couple different data stores. One of them is candidate and one of them is running. And so when you're making changes like in the transaction, you're actually changing the candidate database, and that's how it's doing all the validation. So, it's validating against the other changes you've made, right? Because changes could be dependent on each other. And then it swaps the candidate in for the running database at the commit point. So technically, a reload could be done by simulating a complete, you just parse the entire config and change your candidate and then swap candidate to running. No FRR reload script needed.
Well, myself and the iOS project would be ready to offer help with that part.
Sure. Do you think you could help with the northbound conversion too?
I think yes. And yes, we are definitely very interested in anything that helps us configure FRR automatically from our scripts.
Awesome. Yeah, please do ping us on, I don't know if you're on Slack, but ping us on Slack. Yeah, great. Fantastic.
Well, there's another question. By the way, since you only have one mic, I cannot hear you both when you're speaking.
No, just one mic. If you want to talk to David next, I can hand him the mic.
No, I cannot hear what he's speaking.
Me? He's not saying anything.
Don't conflate me.
What's the question?
Is there any ongoing project to improve the JSON output? Because in 9, there are definitely cases when the JSON is not parsable.
Yeah, you mean, okay, I'm not aware of where it's not parsable. However, the Yang configuration, the models basically are, Yang models are modeling data, right? And so when you query state from the model, you have a schema which is describing exactly the JSON state you're going to get back. In fact, it's just a function call that I make inside, or that we make inside the management D code that says JSON, convert to JSON, or convert to XML, right? It's like because the Yang models can be output in either format. So it's very standardized once you're working with the northbound converted and modeled data. Now, you're right that, we also have JSON results right now that were built in the CLI handlers that predate northbound conversion, and they're just like randomly whatever somebody picked as far as how to model the data, right? There's no schema for it. It's just somebody chose field names and objects and stuff, like for OSPF neighbors, right? There'll be a list of neighbors, and then the neighbors might have metrics or whatever, state that goes along with each neighbor. And that was just whoever wrote that code decided how to format that. So it's pretty suboptimal. But, when OSPF moves from this page that isn't displayed on my screen right now, but when it moves from the not converted to converted, then the OSPF will have a model. And so you'll have a definition for all of the returned oper state. And you just query the model and you'll get back the schema defined state.